All right, so the last problem that I want to touch on is the idea of a function. So if you remember, a function is considered a function if there's only, that's the very important word, only one output, so only one output for every input. So if you remember, our inputs are our x's, our outputs are y's. Our x's are on the left, like in a table. Our outputs are on the right, like in a table. So if you see this input right here of 4 has one output right here and another one right here. That automatically disqualifies this as a function. This is not a function. Not a function. So let's take a look at the example problems here. The mapping does not represent a function. That's correct. Because one x value corresponds to two different y values, which is what's happening here. If you take a look at the other options, B says the mapping represents a function, y as a function of x. That is not true. So we can cross B out. D is also saying that the mapping represents y as a function, so it doesn't matter what the reasoning is, it's not true. C says the mapping does not represent y as a function because there are no corresponding y values that are negative. That is nonsense. So the reason it is not a function is because this one value of x right here has two values of y. This one input has two outputs.